Anesthesia. With great honor, we welcome you to the stage, guiding us through this technological evolution.
Drop the ether or chloroform and provide anesthesia. And if the patient is a very rich patient, affluent patient, they had to have a silk handkerchief. For example, now for Queen Victoria, John Snow used a silk kerchief to provide labor analgesia with chloroform for her. Why I am telling you is, it was so simple. Anesthesia was so simple during those days. But why we required an anesthesia machine? Because one thing with those open drop technique, there is no control over how much of anesthetic you would be giving to the patient. Absolutely no control. Second thing is, the patient would have no control over his airway. And many times these patients would go for deeper form of anesthesia. They used to hyperventilate and they used to even die. That's how, you must have heard about chloroform Hyderabad commissions. 2 commissions were used because there used to be many deaths because of chloroform, because of too much of chloroform. And OT pollution. Probably 50% of what actually the patient would inhale would be inhaled by surgeons and anesthetists. So that was the problem. And another important thing what happened was, during those days, cylinders were introduced. Many of these gases in compressed form was introduced in cylinder form. And in the exam you may be asked, what is a compressed gas? A gas is supposed to be a compressed one if it has a pressure of 40 pounds per square inch at 70 degree Fahrenheit. That is called as a compressed gas. A liquid compressed gas is the one with 40 pounds per square inch above that pressure at 100 degree Fahrenheit. So once the cylinders were introduced, they required a metal frame over which these cylinders could be mounted, and the gases from these cylinders could be mixed in a particular concentration with an inhalation anesthetic agent also being mixed with these gases and delivered to the patient so that anesthesia could be very safe. That's the reason why an anesthesia machine was required, and that was fulfilled by Henry Edmund Gaskin Boyle. That was in 1917. And the first manufacturers of anesthesia machine were British Oxygen Company Limited. They were very magnanimous. They gave the name of the machine to Boyle himself, and they were called as, the anesthesia machine was called as a Boyle machine. Even today, many of the older surgeons, they still call these workstations also as a Boyle machine. Actually, the Boyle's machine is the older one. If even everywhere, if you have a museum, it will be kept for you. I don't think any of you will be using these kind of a machine. But when I had been to Raipur to attend the national conference, I gave actually a lecture on masterclass on anesthesia machine. One of my students who had just passed out from JSS Medical College, Mysore, he had a nursing home there. He came and told me that he has got the old machine in the nursing home. Only one machine, older machine. And when you pass out and then go to the peripheries, many of the smaller nursing homes, hospitals still use the older machines. It is always better you know about the older machine as well. And since after the Boyle introduced the anesthesia machine, it has come a long way. Now what we have is the anesthesia workstations. So since when these have been called as anesthesia workstations? So after 1980, they were called as anesthesia delivery systems. And from 2000 onwards, the name has been changed to anesthesia workstations. So now we have the machine and the workstation. Now one of the thing is, now you may be asked in the exam, what is the difference between a machine and a workstation? A machine is purely pneumatic, whereas the workstation has got pneumatic components, it has got electrical component, it has got electronic component, and also it has got an integrated ventilator and also an integrated monitor. A machine with integrated ventilator, monitor, electrical and electronic equipments, you can call it as a workstation, but most important in the workstation is the safety features. Many of the safety features which have not been there in the original Boyle machine have been integrated with the anesthesia workstation. What is these safety features? Safety features means, so that these safety features have been included so that you cannot deliver a hypoxic mixture to the patient. With the older machine, there used to be so many catastrophes where hypoxic mixtures have been delivered to the patient and patients have even had brain death or even, mortality. Now, the pneumatic system is present in these workstations also. The pneumatic systems, you can call it as the heart of the patient, and electrical and electronic systems, you can call them as the brain of the patient. But, since the gases, you are giving gases, inhalation anesthetic agents, which you can also say vapors and gases, they all have to pass through the workstation and has to be delivered to the patient. So it is the heart of the machine, which is the pneumatic system of the machine, which is the most important thing which you have to learn about. So let us discuss about this pneumatic system of the anesthesia machine. And of course, in this also everything is, pneumatic system is there, but everything is covered. You don't know what is inside. When you are using, actually, it is a total enigma, the workstation. But whereas an anesthesia machine, everything is open. You can see every part of it. And that is the reason it is very easy for explaining things in an older anesthesia machine than in the workstation. But the other important thing is, since this is kept in for you in the exam, and many of the parts, they'll be asking you, what is this, what is this? You would never have seen these parts. It is very important that you know about these parts as well. So, I think you'll be able to focus. Okay. Now, this pneumatic system I was talking to you about has been classified into 3 systems or 3 circuits based on the pressures inside. So it has been classified as high pressure system, intermediate pressure system, and low pressure system. So the high pressure system is from the cylinders up to these pressure regulators. Can you just focus this? This is the pressure regulator. Because why I am showing you this is because you will be asked about what is this. Individual components, they ask you to name. So up to the pressure regulators, it is the high pressure circuit. From the pressure regulators to the flow meter assembly or flow control valves actually is the intermediate pressure system. From the flow control valves to the common gas outlet is called as the low pressure system. So we have 3 systems based on the amount of pressure inside. The high pressure system is basically the cylinder pressures. The cylinder pressures of oxygen is 2000 pounds per square inch. The cylinder pressure of nitrous oxide, it is 750 pounds per square inch. And it is, till the last drop of nitrous oxide is there, it will show only 750 pounds per square inch only. It is a vapor pressure at 20 degrees centigrade of, nitrous oxide. Because nitrous oxide remains as a liquid at room temperature at 20 degrees because of its critical temperature. You have to know about critical temperature also. Many times you will be asked what is a critical temperature. Critical temperature is that temperature above which a matter cannot be compressed into its liquid state. Below its critical temperature, matter can be compressed into its liquid state. Like nitrous oxide, critical temperature is 36.5 degrees centigrade. So it remains as a liquid at room temperature. And what the pressure gauge will be showing you is actually the vapor pressure. So you have the high pressure circuit with cylinder pressures of nitrous 750 and oxygen 2000 psig. So after that, I told you, up to the pressure regulator, you have the high pressure circuit. At the pressure regulator, the pressure regulators will reduce the pressures of these cylinders to 45 pounds per square inch. So from then onwards is the intermediate pressure system. In the modern workstations, we also have the pipelines also connected to the intermediate pressure system. You can just see, I'm just turning this. So this is where you will be connecting the pipelines you all every day you are using. So this is the pipeline. Separate inlets are there for pipelines in the workstations, whereas in the older machines, there is no separate pipeline connection. You have to connect the pipelines using this yoke block to the yoke assembly, where actually you will be connecting to the cylinder only. And now the thing is, the pipelines will be connected in the workstations with a pressure of 55 pounds per square inch to 60 pounds per square inch, whereas the cylinder pressures is reduced to 45 psi. You will be asked again, this is an exam question, important exam question, because it's a safety feature. Why there is a difference between the pressures of cylinder pressure being reduced to 45 psig and pipelines at 55 psig? So what you do every day when you come, first thing you have to open the cylinder, especially the oxygen, because these cylinders are used as backup source of oxygen and nitrous oxide. Actually, they are not directly used for providing anesthesia every day. You all must have done. So you open it because pipeline source is from the liquid oxygen source or the large bulk cylinders kept in the manifold. You have plenty of oxygen and plenty of nitrous oxide through pipeline. Whereas cylinders is a restricted source, and cylinder source is basically used as a backup source of oxygen and nitrous oxide. So you come, open the oxygen cylinder and see if enough pressure is there for you. Whenever suddenly if the pipeline oxygen source gets exhausted, you have to open this. So that's how you'll have to check it and close it immediately. Suppose let us say that you forget to close the cylinder after opening and checking. Now what will happen is, because of this change in the pressure, higher pressure is there with the cylinder and a lower pressure is there with, higher pressure is there with the pipeline, lower pressure is there reduced to 45 psig by the cylinders, by the pressure regulators. So what will happen is, the workstation will be using only the source of pipeline. It will not use the cylinders, because cylinder pressure is reduced to 45. So this is the very important thing you should know, that this is a safety feature. Then you may ask me, so why should I close the cylinder? Let me keep the cylinder open. The problem is, there can be a lot of fluctuations in the pipeline pressure when you are using it. Because, okay, you have started with 1 OT, after some time, 10 OTs have started. In the ICUs also, 10 patients have been connected to the same pipeline source of oxygen. So the pipeline pressure in the workstation start fluctuating. Once it comes down to below 45 psig, suddenly, if the cylinders are open, the oxygen source will be used up. So when actually the pipeline actually gets exhausted, you try to open the cylinder, there won't be any gas in the cylinder. That is why first thing you do is, open the cylinder, check the pressure, close it. Whereas with the older machines, because we used to connect the cylinders to the same yoke assembly, so the majority of the times, if you keep that open, the first cylinder would have been exhausted, afterwards the pipeline. So that is the basic difference. That's why in workstations that has been changed. So that is one thing you should always remember. And from the flow control valves onwards, what we have is the low pressure system, and at the common gas outlet you have just about 7 or 8 pounds per square inch. So the pressures will continuously come down, and by the time it comes out the gases, it will be about 8 pounds per square inch. So this is the different classification of high pressure, intermediate pressure and low pressure system. And again, the parts of the high pressure system, so you have the cylinders, and then you have the yoke assembly. So these are the yoke assemblies. You also must have seen the yoke assembly. It is there. Now here, even in the older, in the modern workstations, you can see these are the yoke assembly. You can just focus here. These are the yoke assemblies in the modern workstations also, where the cylinders are hanged. And then you have the pressure gauges. These are the pressure gauges. Even in the modern workstations, you have the pressure gauges. Unless it is an electronic one, you have the pressure gauge. And then the pressure regulators. I told you, these are the pressure regulators. So these are the parts of the high pressure system. Just briefly about the cylinders, because there can be many questions can be asked for you regarding the cylinders. Safety features will be asked for you in the cylinder. One of the safety features of cylinders is it is made of molybdenum steel. The make of the cylinder is molybdenum steel. Actually, originally when cylinders were introduced, they were made of hand-forged steel. The problem with hand-forged steel was the tensile strength was very less, so it had to be made very thick, so it used to weigh very heavily. So with molybdenum steel, so it weighs less weight. Second thing is it can hold more oxygen, almost 20% more oxygen and nitrous oxide. So that is the advantage, one safety feature. Another safety feature is there are no joints. These cylinders are made seamless. It's called as seamless. No joints, because high pressured gases, if there is a joint, it would open up. So that is another safety feature. The third safety feature in the cylinder is the color coding. You all know about the color coding. Like here, from a distance, you know that it is what gas it contains. The black body with a white shoulder is oxygen. The blue body with a blue shoulder is nitrous oxide. And black body with the black and white shoulders, stripes of black and white is air. And now in 2010, a new universal, this was introduced in 1949, the international color coding. A new international color coding has been introduced in 2010. Now it is being practiced all over Europe. 2025 was the deadline. Now if you go to any European countries, a new international color coding is there. All medical grade cylinders, all body is made of white color. Only from the shoulder you can recognize. The shoulders are color coded, like oxygen is white and white, nitrous oxide is white body and blue shoulder. So this is one thing, plus a capital N is written on the shoulder. That is what a new international color coding. So the other important thing is, you should know, is the pin index safety system. So these are E-type cylinder. A D-type and E-type cylinders have this pin index safety system. So that is again a ASCII question and also a theory question. So you can just see there are holes that are made just below the port of the gas. This is the port. These are the holes. These holes are made at exactly, these measurements are important. Exactly 14 millimeters from the center of the port or 9 by 16th of an inch. So they are made from left to right. They are numbered 1, 2, 3 and 4, 5, 6. Why I am telling 1, 2, 3 and 4, 5, 6 is 1, 2, 3 will overlap on each other. 4, 5, 6 will overlap on each other. 3 and 4 will not overlap on each other. So that is how. And the numbers are again important. You will be asked the numbers for each gas has got a different pin index number. This was introduced by Philip Woodbridge in 1956. Again, that is another important ASCII you may be asked about, or even if you are attending a quiz, you may be asked about Philip Woodbridge, 1956. That's how it came into existence, this pin index safety system. So for oxygen, it is 1,5. So just remember, 2,5. Just remember 5 is common. For air, it is 1,5. For oxygen, it is 2,5. For nitrous oxide, it is 3,5. So how to memorize is air, it is 1,5. 5 is common. A is first alphabet. So 1,5. Oxygen O2, 2,5. Nitrous oxide N2O, 2 plus O, 1. So 3,5. So 1,5, 2,5, 3,5. For N2 oxide, it is 7. Between 3 and 4, so one single hole is there, that is N2 7. And for carbon dioxide, it is 1,6. Cyclopropane, again in the older machines we used to have cyclopropane cylinders. It is C3H6, that is why 3,6 is for cyclopropane. So that pin index safety system you remember. One more important thing about the cylinders is they have a safety relief device. Just below the conical depression, this is the conical depression. You can just show this. This one is a conical depression where the tip of the retention screw will be fitted here. So just below the conical depression, you have a safety relief device. And this safety relief, the most popular safety relief device is called as a fusible plug. And again, this is an ASCII question. Fusible plug contains a special alloy. It is made of cadmium, bismuth, tin and lead. Cadmium, bismuth, tin and lead. It is called as Wood's metal. And this melts at 150 degree Fahrenheit. Very low temperature, it melts. Why this is very important? For example, if these cylinders are kept in sun, what happens is the gas gets heated up. So once the gas gets heated up, it tries to expand. But the tensile strength will not allow it to expand. Like Charles' law says that temperature and volume are directly proportional to each other provided the pressure is constant. But here, because the volume remains constant, the pressure increases, Gay-Lussac's law. Temperature and pressure are directly proportional to each other. Once the pressure reaches a critical pressure, there can be explosion. And even the cylinders can fly. There is a case report where the cylinder which was kept in sun got heated up and it has flown and it has penetrated a 6 feet wall. You can imagine the velocity that it got up, isn't it? So it's very important that the pressure relief device should be there. But unfortunately in Indian cylinders, we don't have pressure relief device. You will be asked again in the exam, where is the pressure relief device? You will be searching underneath the conical depression. It is not there. Actually, where the cylinder valve is screwed into the main cylinder body, in between Wood's metal has been kept. So whenever there is temperature increases, this Wood's metal will melt and it gives vent to the gases. So that's how that is prevented. Now coming to the yoke assembly, we'll just talk about the yoke assembly a little bit. This is also part of the anesthesia workstation as well as anesthesia machine. So the parts of the yoke assembly, you have the main body, you have this is the retention screw, this is the retention screw, this is the sliding gate which slides. And what is important here is you have the pin index pins. You can just see the pins for pin index. And above the pin index pins, you have the nipple where the port of the cylinder is fixed, where the gases will flow inside. And when you fix the cylinder onto the yoke assembly, it is very important that you always look for what is called as a Bodock seal, because the cylinder, the yoke assembly will make sure that there is no leak between the cylinder and the yoke assembly or the machine. So I'll just show you. Fortunately, we have the Bodock seal is there. I'll just take it out. You can focus. So this Bodock seal is very, very important because every day you have to open the cylinder and see, and if this Bodock seal is not there and the cylinder has been fixed, so there will be a lot of leak. So this Bodock seal is very important. It is made of neoprene rubber and there is a peripheral aluminum circumference is there. So why Bodock seal is important? Because of its heavy, thick neoprene rubber. So the wear and tear of this Bodock seal is very, very minimal. So you can use for number of times for tightening the cylinder onto the yoke. It won't have wear and tear. So that is why you should know about the Bodock seal. And another very important thing here is there will be a unidirectional valves will be there inside the yoke assembly. So we have the yoke assembly on the workstation also. So that's why you have to know about. So these are the yoke assembly. Inside the yoke assembly, you have a unidirectional valve. And this unidirectional valve will see that the gases will only flow towards the machine and not away from the machine. But many times what will happen is these unidirectional valves may not be functioning properly. So that is why actually it is not there in this. A yoke plug will be hanging by the side of the yoke with a chain. And why I am telling you is many times it can be there in that machine which is kept for in the workstation, which is kept for you in the exam. So they'll ask you, you would not have seen it. Actually a small metal piece will be there with a chain connected to it, and that you have to, when you are not using the yoke, that particular yoke with a cylinder, you have to close it with a yoke plug. So that is called as a yoke plug, so that you prevent leaking of the cylinder gases. That is one thing. And second thing is, they'll also ask you about what is called as a yoke block. So this also, that's good thing that they have here. So this is called as yoke block. This you would not have seen it, because you can see the pin index holes are there. So this is in the older machines, the pipelines were connected to the same yoke where you connect the cylinder. Because if you want to connect the cylinder, this pipeline, you require to have the pin index holes. So that's how, for oxygen, it is second position and fifth position. This is called as yoke block, and that is yoke plug. So just remember about that. And coming to the pressure gauges. Now you have the pressure gauges. You can see these are the pressure gauges. So just remember, these are the pressure gauges for the cylinders. Once you open, you can see this the indicator moving on the gauge, and these pressure gauges are called as Borden's pressure gauges. So because they have a C-shaped tube, and once the gases enter the C-shaped tube, the C-shaped tube, so it straightens, and to the tip the indicator is connected. That indicator will move over the gauge and give you the pressures. So that is what is Borden's pressure gauge. And in the modern workstations also, we have the pressure gauges. When you have the mechanical pressure gauges, you can see these are the pressure gauges. Safety feature of these pressure gauges in the modern machines, modern workstations, is in the older machines, we had only pressure gauges for cylinders. We did not have pressure gauges for the pipeline. Now we have for pipeline also we have the pressure gauges. You may ask why there is a safety feature. Because so before the alarm whistles, before that only you will know that the pipeline pressure is dropping, and you have to open the cylinders as the backup cylinder. So that is the advantage of having the pressure gauges for the pipeline system also. And another thing about these the safety features of these pressure gauges is they are color coded. You can see the color coding for nitrous oxide, for oxygen, and here you can see the stripes of black and white. That is one of the thing. And in the older ones, you can see a small the disc being covering this hole there here. Small disc is here. So what happens is, suppose this C-shaped tube bursts open. So then what happens is the gases will come out through the back of the machine. They will not enter or come out through the front, because front the patient is there, you are there, surgeons are there, so you can get hurt. So that is the reason this is one of the safety features. Just remember about this also, the safety feature that has been adopted. In the most modern workstations where you have everything is electronic equipment is there, you have the electronic pressure transducers are there. And these electronic pressure transducers will give the pressures of the pipelines as well as the cylinders on the information screen itself. So once you open, you just see in the information screen, you can get the pressures, and continuously the pressures of these will be shown on the information screen in the most modern electronically controlled pressure transducers. Now coming to the pressure regulators. So I told you about the pressure regulators. Even in these workstations, you have the pressure regulators to reduce the pressure of the cylinder pressure to 45 psig. So like the older ones. So why this pressure of the cylinders have to be reduced? Straight away, you people, when we ask you in the exam, you will say that it is to prevent barotrauma. That is not the most important indication. Just imagine that there are no pressure regulators and you are using the cylinder, and you have started with a 3-liter oxygen with a 2000 psig pressure of the newly delivered oxygen cylinder. After say 5-10 minutes, the cylinder pressure will drop down to 1900 pounds per square inch. What happens to your flow? Flow also will reduce. So instead of concentrating on the patient, you will have to concentrate only on your flow meters, only you keep on adjusting. Suppose if I have a pressure regulator, a constant pressured gases will be flowing to the flow meters with only 45 psig, or the pipeline 55 psig, so the flow will not alter. So that is the main reason why a pressure regulator has to be there. And here the pressure regulators, if you just see, if you can focus here, these on this side you have the oxygen pressure regulator, on this side, you have the nitrous oxide pressure regulator. If you just see in the older machines, you have 3 chambers here, 1, 2, and 3 for nitrous oxide. You have only 2 chambers for oxygen. And you can see this is the oxygen piping. The oxygen piping is coming to the nitrous oxide pressure regulator. I hope you are able to see. This is the oxygen piping. It is coming to these are all oxygen piping. And because oxygen pressure is there, then only nitrous oxide will be released. If the oxygen pressure is not there or low, less than 30 pounds per square inch, you cannot give nitrous oxide. And this system was called as master and slave mechanism. Master and slave mechanism in the older machines. In the newer machines or in the workstations, this has been replaced by fail-safe valves. I'll just come to fail-safe valves when I discuss about the intermediate pressure system, because that will be there in the intermediate pressure system. These fail-safe valves are there between the pressure regulator and the flow control valve. So in between, now this master and slave mechanism is not there. We have the fail-safe valves. Okay, now this is about the the high pressure system. We'll just check about or talk about the intermediate pressure system. So intermediate pressure system, first thing you should know is the pipelines. The pipelines in the modern workstations are in the intermediate pressure system. So the connections of the pipeline, I showed you the older machines, the connections were the same to the yoke assembly. Whereas now here you have separate connections. So you can see these are the inlets for the pipelines. So what is special about why there is a separate inlets, and also there is a safety system here. Like pin index safety system, what we have is diameter index safety system. You can just see, it's okay. You can just see, this is the diameter index safety system. You have a nut and a stem. You just see this is oxygen and this is nitrous oxide. You can see the diameters are different. Can you see inside diameters are different? The same way the nitrous oxide diameter is different. Similarly, this diameter and this diameter, they have to align. Then only you connect a particular, for example, oxygen piping to the oxygen inlet. That is what is called as diameter index safety system. There is something called as a NIST also. This actually is a NIST. NIST is non-interchangeable screw threads. The difference between diameter index safety system and NIST is, in the NIST, the screws are not same diameter of all the gases. It is only the nut or the stem which is diameter index. So the British-made machines have NIST, whereas American-made machines have diameter index safety system. In diameter index, both the nut and the stem are diameter indexed, whereas in NIST it's only the stem. So that is the difference. And again, on the wall side also there are actually diameter index. These are at the wall outlet you fix the oxygen and nitrous oxide and all these. So they also have a different kind of diameter index. But they are not called as diameter index safety system. They are called as Schrader valves or quick couplers. Quick couplers, you can couple and uncouple quickly, but they are again diameter index and they are all color coded. You can just see the piping is also color coded. So that is about the diameter index safety system. Then the other important thing I was telling you is the fail-safe valves. The fail-safe valves are there in between the pressure regulator and the flow control valves. And there are two types of fail-safe valves in the Draeger type of machine and GE. So this is almost like a GE machine only. In GE machine, what you call it is a shut-off valve. So if the oxygen pressure drops to less than 30 pounds per square inch, it shuts off nitrous oxide. You cannot just use nitrous oxide. It is called as a shut-off valve. Whereas in case of Draeger, what you have is OFPD, oxygen failure protection device. In this oxygen failure protection device in Draeger, what it does, once the pressure of oxygen drops down to 50 psig and starts coming down, it simultaneously starts reducing the nitrous oxide pressure also. It is in the fail-safe system, not in the proportionating device. It acts as a proportionating device, and then once the oxygen pressure drops down to 10, it totally cuts off the nitrous oxide also. So slight difference between GE machines and the Draeger machines regarding the fail-safe valves. One is a shut-off valve, another one is oxygen failure protection device. So you may ask me, when you have these fail-safe valves, why should we have the proportionating devices like Link 25 or SORC, or sensitive oxygen ratio control? That also we'll discuss. That also I'll have to discuss in the low pressure system. So that is because fail-safe valve is a misnomer. With the fail-safe valve, it is pressure sensitive. As long as you have opened or connected oxygen source is there, which is passing through this fail-safe valve, you can still give only nitrous oxide. Whereas that is the reason, if you have again a proportionating system at the flow control valve level, then even because that is flow sensitive, these are pressure sensitive. Fail-safe valves are pressure sensitive. Even when you open or connect it to oxygen source, because of the proportionating devices, you cannot give less than 25% of oxygen. That is at the proportionating devices, they are slightly different. We'll come to that later. Now one more thing you have is the oxygen failure alarms. You can see, you just, it will be there inside the workstation. Can you show? So this is actually, he is tired actually. So this is the alarms. So once the pressure drops down, these electronic alarms, originally we had pneumatic alarms. They were called as Ritchie whistle or Bowman's whistle. Now the problems with Ritchie whistle or Bowman's whistle, they used to operate with oxygen. So if oxygen, a small cylinder used to be there, a canister. If oxygen cylinder gets exhausted, then they would stop. Now present standard says that till the oxygen source is again regained, till then you have the alarm should continue. It's a high priority alarm. So these electronic alarms, which is also there in these, they are both the audible alarms are also there, visual alarms are also there. So that once it comes down to 30 psig, whether it's a Draeger or the GE system, the alarm will start and it will continue till you open a backup source of oxygen. So that is another part of the intermediate pressure system. One more thing is the oxygen flush. So you all must have used, this is O2 plus, it is always there. So once you activate it, 35 to 70 liters of oxygen will flow out of the common gas outlet. 35 to 70 liters at the same pipeline pressure of 55 psig, because it is directly connected to the pipeline source or the cylinder source. It bypasses the flow meter assembly and also the vaporizers. Once you activate the flush, so 35 to 70 liters of gas at 55 psig will go to the patient. So when you use it, how many of you have used oxygen flush anytime? Used? No, with confidence you can raise your hand. Why like this? So when we use it, suppose I am holding a mask on a geriatric patient with so much of, edentulous patient, there is so much of leak, or a morbidly obese patient, you are not able to ventilate with a mask. Then you activate it so that you overcome that leak by using extra amount of the oxygen source, that is 35 to 70 liters. So then again, Dr. Banguera will be talking about Pethix test. In Pethix test for Bain circuit, again you will be using oxygen flush. And so many times you have the bellows ventilator, quickly you want to fill the bellows ventilator, you would be using the, the flush. And one more time is Sanders jet ventilator. That also can be, intermittently you can use. I'll take another 5 minutes are there? How much time is there? 5. I'll take 10 minutes. Another extra 5 minutes. So that is oxygen flush. But there are problems can occur, because I was telling you there are two problems. One is a barotrauma. Unnecessarily if you just compress it, So suddenly so much of high pressure gases going to the patient with, if you have connected a endotracheal tube, it can definitely produce barotrauma. And second thing is, because it is bypassing the vaporizers, the patient become light because no anesthetic agent can go. So these are the two problems with oxygen flush. So especially with Draeger machines with a piston-driven ventilator, so when you activate it during mechanical ventilation, because there is fresh gas flow decoupling valve is there in Draeger, directly when you operate the flush, the oxygen we cannot directly go to the patient. It will go only to the bag. That is the advantage of the fresh gas flow decoupling valve which is present with Draeger. So the bag can burst but not the patient's lungs. So that is the advantage of fresh gas flow decoupling valves there. Now coming to the low pressure system, of course there is one more second stage pressure regulator which is there in the intermediate system, that is there only in GE machines with a Link 25 proportionating device that will further reduce the pressures from 55 of oxygen and nitrous oxide to oxygen to 14 psig and nitrous oxide to 26 psig. So that when the pressures come here to the flow control valves, the mechanical flow control valves, the pressures are very low. 14 of nitrous oxygen and 26 of nitrous oxide, so that the flow will be more accurate, second stage pressure regulators. Whereas with Draeger, you don't have a second stage pressure regulator, what you have is a flow restrictor. What they have done in Draeger is, some of the Draeger machines, is as the gases come through the tubing into the flow control valves, they are narrowed. When gases pass through the narrowed portion, what will happen? Bernoulli's principle. The velocity increases, the pressure drops. So automatically, instead of a second stage pressure regulator, they have reduced the cost. So the pressure automatically reduces by the time it will reach the flow meter assembly. Now coming to the flow meter assembly, now we have the flow meters, the flow control knobs. These are the flow control knobs you can see here. So in modern machines, in the older machine, if you just see, one tube for oxygen, one tube for nitrous. The problem with these single tube for each gas is very difficult to go for low flow anesthesia accurately. Suppose I want to just give 250 ml of oxygen, metabolic flow, as far as low flow anesthesia is concerned. I will not be able to provide with these machines. Whereas with the modern workstations, you have two flow meters for each gas, for oxygen, nitrous, and air. So that the first tube is for low flows, that it will have only 1 liter, and subsequently it is in a series, so that goes to the higher flow. Second flow meter is for higher flows. So that's how it is a safety feature for having an accurate flow for low flow anesthesia. And these again, the flow control knobs, whether it is the newer machines or the older machines, they are also color coded and touch coded. I need not have to see. If I am touching here oxygen, I know, because the flutes are wide and color is white, and these flutes are narrow. And that's how, by touching also, they are touch coded and color coded, again, that you should know. And there is a shield here. You can see the shield. And this shield is to protect these flow control knobs. So I still remember when we were PGs, our friends used to come and then, lean on these flow meters. They used to do like this. So that would, make the flow dancing. So that's why, to prevent that, so a shield has been, so unnecessarily somebody cannot handle this. Everything is important. They will ask you these things. And coming to the flow meter assembly, between the flow meter assembly and the flow control knobs, you have the proportionating devices, which is called as a Link 25. In case of GE machines, even in this Penlan, you have Link 25. They are mechanical proportionating devices. 95% mechanical, 5% pneumatic. Whereas in Draeger, you have SORC, sensitive oxygen ratio control, or that is actually 95% pneumatic, 5% mechanical. Now, how do you recognize? You may be asked in the exam. So what you have to do is, so you try to open nitrous oxide. If you try to open nitrous oxide, if oxygen flow control knob also moves, then it is linked 25 because they are mechanically connected, sprockets are there, teeth are there, 14 teeth for oxygen and 28 teeth for nitrous oxide. So you have to rotate twice oxygen to open nitrous oxide. So you can just see, if you concentrate it here, can you see? So I'll just go back again. Can you see the rotation of oxygen also? I am actually rotating nitrous oxide. So you do that. If you are asked, okay, what kind of a proportionating device is there in your workstation, just try to open nitrous oxide. Oxygen flow control knob also start moving, then it is linked 25. If it is not there, then it is SORC, sensitive oxygen ratio monitor. Then coming to the flow meters as such, these flow meters are called as Thorpe tubes. Thorpe tubes because they are tapered. As they come down, they are narrow. As they go up, they are widened. So Thorpe tubes, and they are made of plexiglass, very hard glass, and it will not break easily. Third thing is, their inside, it is sprayed with a special chemical which is called as Croxtine. This Croxtine prevents static electricity. So what happens is when bobbin moves, it creates electricity. The electricity should not stay there. If it stays there, the bobbin gets stuck. Once the bobbin gets stuck somewhere, okay, at 3 liters, even if you are giving 6 liters, you don't know. That is why this Croxtine has been sprayed inside so that it is an anti-static material. It prevents the bobbin getting stuck there. So that is another very important thing. And each tube is calibrated for a particular gas at 760 millimeters of mercury and at 20 degrees. And they have a pin index system there so that you cannot exchange these flow meters. Because each gas has got a different density, different viscosity. So the flow meter has to be, calibrated according to the density and viscosity of that particular gas. So you cannot exchange the flow meters. So that is another one. And stops are there above and below so that the bobbins cannot be lost. And these flow meters are called as constant pressure variable orifice flow meters. Constant pressure variable orifice. Because it is it is tapered as it comes down, and as it goes up, it is wide. That is why it's a variable orifice. Variable orifice, constant pressure. And arrangement of these vaporizers is called as Eager's arrangement. Eager, E-G-E-R. Eager, you must be knowing, he was the person who defined MAC. Minimal alveolar concentration. Eager definition is there. Eager, the arrangement is there. Oxygen should be the downstream, most downstream. And why it should be downstream? Because if it is upstream, if there is a break in any of these flow meters, so then oxygen will leak out and patients will be getting only hypoxic mixture. That is Eager's, this thing you should also know about. And with most modern workstations, you don't have mechanical flow meters. You have electronic flow control. And there are a lot of advantages with electronic flow control. One advantage is you cannot give hypoxic mixture. So minimum FiO2 you can go for is 25%. You cannot go less than 25%. So that is one advantage. Second advantage, you don't go for so many liters of flows. You just go for FiO2 this much and total flows. It automatically adjusts. Third thing is, whenever there is fluctuations in the pipeline pressure, there won't be change in the flows. Flows will be very accurate. That is the third advantage. The fourth advantage, you must have known about target controlled inhalation anesthesia. With the electronic flow control, they assist in target controlled inhalational anesthesia, TCIA. So these are the advantages with, and there are still so many things I would have spoken to you, but lack of time. So if you have any doubts, you can always ask me anytime. You can take my number from the organizers. You can ring me up anytime. Not only regarding machine, you can ask me anything or WhatsApp me. I'll be always, eager to help the postgraduates. Thank you so much. Thank you.
Thank you, sir, for this amazing session.